আমি চিনবো তো বুঝছেন তো না কোনো সমস্যা নেই কখন আচ্ছা তুই পারতে না পড়ার বিজনেস ম্যান কম্পিউটারে আমি ইন্টারেস্টেড Where is Tom Mandawar? Where is Tom Mandawar? এটা হয় yes yes বুঝছি মজা করছি মানে আমরা ইয়ে পেট্রোল আছে আমরা খালি এখন করছি নট এ লট আচ্ছা হ্যাঁ ঠিক আছে ইয়েস ইয়েস রাইট ইয়েস হ্যাঁ পাওয়া যাবে কিছুই না তো এটা হয় ইয়ে হয় এটা হয় রাজমা ভাত আর দই না না তুমি দেখো এটা হয় এমনি হয়ে গেছি কিছু বলবো না ভাই এটা তো আমাদের গেছে বাসে। Sure. चलो I बाइक तो कोई ना कोई देखिए ना डिमांड से ना ना চিন্তা না আমি তো স্লো একটু না রাতে ঘুমাইছি না ইন্টারনেট এক্সপ্লোরার হয়ে গেছে না শুইলে এখন ঘুমাইছি না শুই আর কখন ঘুমাইলে আবার এই লুপ কন্টিনিউ হইব এই লুপটা ব্রেক করার জন্য একটাই রাস্তা আজকে না ঘুমাই না রাত ডাইরেক্ট রাত্রে 9টার পরে ডিনার করে ঘুমাই আজই ফেলি আজই ফেলি এইটাই একমাত্র জিনিস যেটা আমার ঢোকার বেকার প্রেজেন্টেশন বানায় এখন লাভ নেই আজই মতন মিশন তো পার হয়ে গেলে ভাই মিশন পার হয়ে যায় एग्जैक्टली भाई আমি তো এটা করি কি আমার আধা লেভেল শেষ করতাম ইয়েস না আমার ইজি গেমসও লাগে আমার ইজি গেমও লাগে আচ্ছা আমি যত অ্যাকচুয়ালি আমার মডেলে লাগে দেখি কারেন্ট ও মানে অ্যাকচুয়ালি আমার একটা জিনিস পড়ার আছে কিন্তু আমার এনার্জি নেই জিনিসটা পড়ার মানে যে জিনিসটা পড়ার যে এনার্জিটা লাগে
Uh,
এটা এখন নাই আমার কাছে
okay,
বাট
K.
করবো
Pandi.
কোনটা
We are going to start today's
আমার
session.
মনে হয় তুই খালি কইস অমিতাভের কথা
Uh,
কটা
just one student, as you see.
না জানি এটা তো বুঝছি
But okay. So first we'll cover what we had
এমনি
done. We
বেসিক্যালি
had
জিজ্ঞেস
left
কখন যেন মার্ক
previously.
ক্যারিয়ার
That is the
হোয়াট ক্যারিয়ার
hidden
অপশন ফর
Markov model. Okay,
না না তোর
three questions left here.
জীবন থেকে
Acha. So
তোদের
first I'll
আমি
present.
বলি গেলে তুই মনে করাস না না আজকেই আমি একটু এনার্জি আইলে কিছু না একদম চল করবো
K. Pandi, maybe other people have, I think, uh, lost the timing as it is 2 hours before. Uh, okay, so so let's get started. Okay, so these were the questions left previously, 8, 9, 10. So we're going to cover that. Uh, just before that, just to brush up the things so that you don't get lost in here. Uh, we'll cover just the theory a little bit. Okay. So the hidden Markov model is the important thing is the states are there, as you can see, S1 to Sn here, and so there's a process so that we are moving from one state to another. Okay, so most important thing is this Markov chain property, in which one state is dependent only on the previously immediate step, and so these are the two things mentioned. Transition probabilities, as you can see, aij is like this. Okay, so j is immediate of I. Okay, immediately before I, and initial probability here given as the p of si. Okay, so is it audible? Is it audible? Okay. Better if you reply, be easier. Okay. Okay, let's progress then. So as you can see, there are, here it is here is the example. So will it rain or will it be dry? Okay, so these are the two states given here, rain and dry. Okay, so the initial probability, as you can see here in this question, psi is there. So S1 and S2, rain and dry, 0.4 and 0.6 given. Okay, and next, as you see this transition probability, so you can see the transition may happen from uh, the one state to the same state as well. Okay, so rain to rain transition is there, means one day is rain, second day is also rain. Okay, so those are this given, those are the probabilities given here, and and so as you can see, so this is the total probability. Okay, means the joint probability, or you can say the, okay, joint probabilities it is called. Okay, so it can be written as like this. Okay, sk dependent on conditioned on s1 to sk minus 1 multiplied to s1 to sk minus 1. Okay, so this is the conditional probability theorem. Okay, and as sk is dependent on only on sk minus 1, so you can write it as p of sk given sk minus 1. Okay, and so you are left with this one, s1 to sk minus 1. So inductively you can write it like this. Okay, last as you will find is s1, which is independent of uh, every other state. Okay, so example is given as well. Okay, so so we have to find the probability of the sequence of states. So first day it is dry, second day it is dry, third day it rains, fourth day it rains. Okay, so this is the one. So we actually start from the last one here. Okay, so probability of rain, given rain, sk minus 1 first is there, then rain, dry, dry, and then final one, dry. Okay, so just multiplying the probability to get the answer. Okay, so something like this. And another thing important is here are the states are not visible, so that is why it's called hidden Markov model. Okay, but observations can be there. Okay, so or you can say it as visible states. Okay, uh, so a hidden Markov model is defined by three parameters here: A, B, and pi. So pi are the initial probabilities, okay. So there will be a vector of initial probabilities for each s1, s2, s up to sn, okay, like that. And next what we'll have is the transition probability, okay, which will be a matrix, as you can see in this question as well, question that we have. uh, so in this question, as you can see, the transition probability is a matrix here, okay. So that is what they have mentioned in the here as well, okay. So their observation probability can also be there, okay. So this is also a matrix here, okay. And next what we have is a hidden Markov model here, okay. So so this is the observation probability is also given, okay, that so high or low atmospheric pressure is given. These are the hidden states, and observation is rain or dry, okay. So likewise they formulated this one, okay. So as you can see, uh, observation probabilities is given, okay. Rain happens given which low pressure condition on high pressure condition. So likewise they have conditioned upon, and initial probability are this, okay, si1, okay. And these are transition probabilities. So in this problem, okay, what they are saying is like first 2 days are dry and rain, okay. Means dry and rain, okay. So first 2 days are dry and rain, under which condition it might happen, okay. So we need to find the probability of dry and rain, but it can happen in low condition, low high condition, high low condition, high condition, okay. So all these are added up, okay, to find this one, okay. So one they have calculated, okay. So it is the conditional, so it is a total probability, joint probability is equals to conditional probability into this, okay, that conditional probability theorem, okay. So they have used this one, but again they have broken up this one, okay. And as you can see, this dry is not dependent on so as dry is dependent on low, so they have written it like this, and rain is dependent on low, so that is why here, okay. So this is there, okay, some type of hidden Markov model, okay, are there some examples, okay. So this is it, we cover up to this and then go to the problems, okay. Okay, uh, so answers are already available, as you can see. So where where does the additional variables, prepare the slides as well. Just wait a minute. Okay, so let's continue. uh, so uh, so this question is there, so additional variables are had added in hidden Markov model in temporal model, okay. So this is the answer actually, I think it is taught here. uh, Maybe not. So as you can see, this is actually time changing with time. Okay, so that is why it is called temporal model. Okay, and so this additional variables, the hidden variables added, so that is what they're talking about. Okay, so this is it. Next next problem that we have here is that, so so under restrictions of this simple models. Okay, like in logistic regression, like sigmoid is used like that, so those can be implemented with hidden markov model under some restrictions. Okay, that is why it is called the restricted structure of hidden markov model. So nothing much here actually. Now we come to this question. Okay, so as we're continuing, we come to this question. Okay, so anybody has done this question? Question number 10, hidden markov model. Hello, uh, maybe little active if you would be. Is it audible first? Speak up. Okay. Okay. So have you done this question? Any reply? Not yet. Okay. So actually, I wasn't able to match the answer here, so I was just checking. Maybe I am wrong. Maybe the question maker is wrong. So as you can see, so the day one. So let's check it out yourself ourselves right now. So the day one is sunny, they have told. Okay, what is the probably the next weather for the next 7 days will be this. Okay, as you can see, these are 7 days: sunny, rainy, cloudy, sunny. Okay, so these are the uh, situations or states, you can say, that are given. Okay, so we have day one here, and then 7 days. Okay, so 2 to 8. Okay, next, as you see, so we'll as we need to find the uh, actually, as you know that we go backwards while calculating these probabilities. So we start from sunny here. Okay, so we need to find probability of sunny given cloudy, probability of cloudy given rainy, probability of rainy given rainy, then probability of rainy given rainy. If I'm doing something wrong, point it out. Okay. Okay. uh, so then we are having rainy given sunny. Next we are having sunny given sunny. Okay, so this one, and another one is still left. As you can see, this was sunny. Okay, so again it will come probability of sunny given sunny, then probability of sunny, which is given, it is 1. Okay, already defined, this is 1. Okay, so you just need to fill these values. Okay, uh, so first is probability of sunny given cloudy. Okay, so as you can see, sunny is actually third one, cloudy is second one, so it is 0.1 multiplied CR. Okay, so cloudy is second, R is 0.2. Okay, so this is 0.2 cross option A is the answer. So you've done it right. So let's see what is the answer here. Yes, option A is the answer, but like I was actually not getting it. Means like maybe I've done something wrong. You've done it right. So you can point out what error, what I'm doing, what problem I'm doing. Uh, but actually, means the thing is here actually that we, as you can see, 3 times rain is there. Okay, so 2 times PRR will be there, right? So actually the problem is here only, or I don't know, means like if they have done wrong, because like they have done is like they have taken one PR R given R. Okay, but how it can be, I don't understand actually. There are, as you can see, first is like C given R given R given R, then R given S. Okay, so that is what I'm getting. So like, so K Pandi, like what you have done means like option, means like how did you get it, means you can point out the problem if I'm doing anything wrong. Okay, so R given R is rain given rain 0.4. So actually I'm taking 0.4 two times. Okay, but they have not taken it 2 times. What you were writing? ABCD. What is ABCD here? Achha, F E E D D C C B B A. Of course, but like, of course that is, but so that is what I have done as well. Same actually I have done, but not getting the answer, as you can see. So Sunny SC CR RR RR RC SS SS, then S. Okay, is there any problem with this one? Starting from here, then I've written. Any problem with this one? What I've done? Is it correct? Hmm? Anything? Well, it is wrong. How is it? It should be opposite. Actually, I've started from the behind as well. Okay. So if you can unmute yourself, can be easier actually. Uh, 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 Same thing I've done actually. Means like the event which has started the means which has happened the last has to be first. Okay. Sunny has to be first. Okay. Sunny given cloudy like that. Okay. Order is not a problem. Okay. Order is correct. As I said, this one they have used one time. PR given R. They have used one time. It should be two times, right? Hmm. Agree? You can unmute yourself. Like, order is correct, right? Order means like I've started with the last one has to be written first. Okay. S given C has to be first. Okay. That is what I've done. There's nothing wrong in order actually. You can make your point like unmute yourself like it is very hard this way.
Yeah, so I was just saying, what if it's the opposite, like that? Uh,
The or
like the first event happens with some probability, and then what is the probability of that second event
no in
happening, given that the first event happened? First,
means
second is that whatever the sequence is that we want to
when
have.
writing the sequence like you have to do it the last one first, right? Means this dependence of this event is on this one, then this one is dependent on R is dependent on another R like that. That is how the sequence is flowing, right? But anyway, like this one actually is the problem actually. Okay. So they have only used a, so if you have done it like are you getting the answer, or so if there is single 0.4 you'll get the answer. And R given S is R given as 0.3, PSS PSS uh, S is this one, right? So 0.8, 0.8, then 1. Okay. So this is what I'm getting. Okay, if you remove one this 0.4, you'll get the answer actually. With this, 0.4 I've got three times this time. Let me see. Hmm. Uh, I've written it twice, I think. So PCR is CR is this one, 0.2. RS is what? RS is R and S is 0.3. We need two times actually. So this one will not be there. Okay. So this is the one actually. Okay. This is what I'm getting.
Okay, so whatever is given that data, let's say A given B, so it means that probability of event A given that B has happened, right? So the given event has happened earlier than the one, right?
What I'm
So if
saying.
you,
Uh,
so any element of the matrix is some sort of an A given B, right?
hmm.
And that if you have to use that in the problem, in so that way, if it's A given B, then B has to happen before A, right?
If A given B, then B has to happen before A. Yes, correct.
Right. But if you start from the last,
Uh-huh.
then if you do that, let's say you start from the last, then you have to use the last and second last conditional, right?
Yes, that is what I've used actually. As
But
given
for
C.
that you need uh, probability of uh, second last. I mean, that is not defined, right? How are you going to do that? I mean, you see, uh, the second, I mean, you are starting from the last, so you have, you know that this say last has happened already, right? Now, when you move from the last to second last,
So it is not that complicated actually.
y-
See, just these probabilities are given. Okay. In timeline, what happens is you are saying that this will happen so that C.
no, I'm just saying that that order is wrong. Like if you start from last event,
Uh,
then you cannot. I mean, multiplying the probability is fine, but that is not defined here. That because the last event has
yes,
happened.
chronologically not correct, but as you can see in
Yeah,
probability terms, this is what happens, right? S is dependent on C, so I cannot write it from here actually. Okay.
yeah. That is why I was saying that start from the
But the
first
answer
only.
will be not be different, right? If you start from here, okay, this is unintuitive, okay, but but what happens? The answer will still come the same, okay. But if you reverse the order, like that can get wrong. But the main problem is here actually. This what they have used is like two times I'm using this one, which it should be okay, but they have used it only once in the answer. Uh, so
So how do you get the probability of a single event? Any of these as like.
huh? Okay, what you're saying?
So the matrix elements are a conditional probabilities, right? How do you get a single
This one
event
you are saying.
probability? Yeah, yeah, any of, let's say.
So that's not very hard actually again. So as you see, so the weather on day one is given sunny. So probability is one, right?
It is already given sunny. Okay, okay.
Uh, okay, clear. So check this one. I don't know where I am wrong. You cannot point it out as well, but there may be something. Okay, but there are three rainy here. How can it be one only conditional? What am I missing actually? Not sure about that. Okay. Okay. So should we progress? Okay. Uh, so let's progress. Ensemble methods. Okay. So we'll just go over brief over the lecture notes first. Okay. Then we'll get to the problem. Okay. So this ensemble methods are like mostly used for reducing the variance. Okay, of the model. It can also reduce the bias as well in case of boosting models. Okay, and so this is the general idea, as you can see. So multiple data sets from the original data set, a multiple classifier build upon that, and then a final classifier to get our answer. Okay, so first we have talked about stacking, then bagging, then boosting. Okay, so it's an example. Okay, so there are several models. Okay, like SVM and decision trees, KNN, like that, spam, non-spam. Okay. Okay, so let's progress. Okay, uh, so okay, so the stacking one, as you can see, these are this example is all for the stacking one only. So you have several models. Okay, this is first level learning. Okay, and they classify accordingly whatever it is. Okay, or can be regression as well. Okay, then what you are taking is the final model. Okay, second level learner or meta learner it is called, as you can see. And so this is what is stacking. Okay, finally you can have a voting or averaging. Okay, to get the output. More interesting it is bagging. Okay, which helps in reducing the variance of the model significantly. Okay, so here we are doing sampling with replacement. So what does it mean? I think here it is given. So we are sampling, but you're also keeping a copy in the original uh, set that you have. Okay, so the original set does not change. So what happens with that is that the main data set is preserved, and so the one sampling does not damage the subsequent sampling. Okay, so that is why it is important. Okay, so you prepare several data sets like that. Okay, train several models on that. Okay, and then combine the inference of those. Okay, so in stacking, as you can see, several models on single data set, so single complete training set you're training on. Bagging or bootstrap aggregation, just random sampling with aggregation replacement we are doing. Okay, and boosting, so we are using weight over misclassification, increased weight. Okay, so how does it help is that uh, this if you increase the weight, then on the misclassified one, then your model will work better, uh, focus on the samples which are misclassified more. Okay, so bagging here explained the algorithm. Okay, in a proper way. So as you can see, so the original data set. Okay, with n training examples, so make m such data set in such that number of training example each dm is n. Okay, so that is how it is created. Okay, so as m data sets are there, you train m models over this data set. Okay, then we use averaging of the model. Okay, it's very useful for high variance situation. Okay, overfitting situation. Okay, so one example of bagging is given. Okay, as you can see, so there are three data sets prepared from this. Okay, random sampling with replacement. Okay, so and they are classified with some ordinary algorithms. Okay, SVM it can be, or KNN or something like that. Okay, then we average those models to get this averaged model. Okay, so one of the best example of this bagging is random forest, very popular algorithm. Okay, so in random forest what we are doing is So in random forest we are, so that, so as you can see there are n data sets prepared, okay, 1 to n. Okay, so as you can see, the strength has increased considerably compared to what was before. So we're covering this ensemble methods, okay, and so we are on to bagging here, okay. The one of the most important example of bagging is random forest, okay. uh, so we are on to that. So where is well, so so this is it. So random forest, you have randomly sampled n data sets, okay. You are training n decision trees over that, okay, and the classification is based under voting, okay. So this is the averaging in this case, okay, and then we are making the prediction, okay. So this is it really. uh, some examples as you can see. So for every tree, t1 to t2 t3 are made, okay. So root node, lateral node, leaf nodes, nothing important here actually. Actually this is important. Given a total of d features, each decision tree uses so it is choosing randomly chosen features, okay. So that is why the decision trees are uncorrelated, means there is no relation between each other, so their decision is independent of each other actually, okay. So the classification, when you are averaging, so you don't need to give one more importance to someone, less importance to something, okay. So you can give them equal importance, equal weight, okay. So this is one important point here, okay. So next is, next is boosting here, okay. So boosting, what we are doing is, first we are using the whole training data to train the model, first model, model 1, okay. These preliminary models are called weak classifiers as you can see, and then what we are doing is, that the misclassified samples are given a higher weight, okay. So likewise we are creating a higher weighted samples for misclassified one, while giving lower weight to the correctly classified one, okay. Then training again, and training again, however you want to do, okay, how much you want to do. Finally combine these strong classifier, okay. So then we are getting the output, some sort of averaging here, okay. So boosting, as you can see, trains a weak model on some training data. So higher weightage given to model in which it is making mistake. uh, okay, nothing. So one of the most popular algorithm of boosting is ADA boost algorithm, okay. uh, so here you can see x1 to x means supervised data classification data. As you can see, y can be -1 and 1, okay. So supervised classification data and training points. uh, so initially we are giving equal weight 1 by n to each data point, okay. So the weight d1n, okay, 1 represents the first step, okay. N is for each, we are giving 1 by n, okay. So for then we are making rounds of this boosting, okay. So t rounds are there, total t, capital T. So from t equals to 1 to capital T we are doing the exercise, okay. So first we are doing is a first weak classifier, okay. Okay, so we train that weak classifier on the data that we have, okay. So So then what we are doing is, as you can see, we are creating weighted functions of errors of ht. Okay, means misclassification that are there, they are simply added up. Okay, for every h t x n not equals to yn. Okay, whenever they are unequal, et increases by 1. Okay, you can say like that. Not 1, I think. It is the, is whatever weight is there. Okay, first step it is 1 by n. Okay, suppose the 3 misclassification, it is 3 by n. Okay, so like that. But whatever weight may be at say subsequent steps, just that is added. Okay, for the training examples. Okay, and so they have defined a function alpha t as the importance of hi. Okay, of that model. Okay, of that classifier, weak classifier as they are called. Okay, so that is defined as alpha t here. Alpha t is half of log 1 minus so like that, as you can see. So as you can see, as they are wrongly classified, so their weight has to be increased by multiplied by higher than one number, as you can see, exp to the power alpha t. Okay, like that. So so that is it. Okay, if they are correctly classified, they are actually dividing it by the same value minus alpha, as you can see, the power. So this is like a better, like simpler representation. Okay, and next what we are doing is that so d are the weights for each samples, right? And so we are now normalizing this one tt1. Okay, such that the sum becomes equal to 1. Okay, for every, so as you can see, the summation is from m equals to 1 to n for, like, so what does it mean? At tth step, or t plus 1 is it, t plus 1th step they have written. Okay, so the weights sum, okay, is equal to 1, because like after this operation it may not sum up to 1. Okay, initially we have started like it will sum up to 1, but after all this it may not sum up to 1. So at that step we are normalizing the weight. Okay, so the final output, as you can see, defined as like this. Okay, so example given for you, should see this one before going to the exercise. So 10 data points are given, so each weight is 1 by 10. Okay, weak classifier acts as parallel linear classifier. Okay, so after round 1, okay, round 1, what we see, this line is the classifier. Okay, so error rate, okay, so 3 times 1 by 10, 0.3. Okay, so this is it. Okay, and weight of h1, as you can see, alpha 1 they have calculated as this. Okay, and each misclassified point up weighted. Okay, so weight are increased for the misclassified one, 3 are misclassified here. Okay, so this is the one. Okay, so now we are looking at round 2 here. Okay, so round 2, what happens is that okay, so in round 2 what happens is that the weight has increased. As you can see, the initial weight was 1 by 10 into exponential whatever that is. Okay, so error rate is whichever is misclassified. Okay, so misclassified are these 3. Okay, so 3 by, I think, 0.7 is the misclassification, means weight for this one. Okay, so if you can see, So the thing is that this is the one, right? So first 1 by 10 into exponential power is minus 0.42. Okay, so 1 divided by 10 multiplied exponential is exponential exponential is not there, but we can manage with the approximate value. Acha is there. Okay, to the power is what is the power minus 0.42. Okay, 0.22 I think it is like is what was given. So error rate they are saying or this should be 3 times, right? Uh, let's see, e to the power minus 0.42. So what happened here is E2, right? E2 is defined as the sum of the misclassification weights. Weights we've already changed. Misclassification rate. This is the dt that we are calculating here. Okay. We are adding it up. It is like 3 by 0 point, then it is not working. Maybe they forgot to change it. Similarly we progress, and so we get the answer like that. Okay, and so as you can see these classifiers are added. Okay, like this, and then we get the final classifiers. Okay, so bagging versus boosting. Okay, so both can reduce variance, but boosting can only reduce bias. Okay, so that is one important. Okay, bagging performs better if not high bias. Okay, and so computational complexity problem is there both. So we move to the problems. Actually, problems are actually easy. So in adder boost, as you can see, so the weighted sum of weak learners is the answer, as you can see. So just saw. So as you can see, with the theory done, the questions are actually very easy, nothing here. So weighted sum of the weak learners, right? Next, boosting assigns. Wow, this one is different. Boosting algorithm assigns equal weight to all training instances. That's not correct. So you have to interpret it like this, okay? I think this is what they're talking about. Difficult of each instance. How difficult is it to classify each instance? It's like it is making mistakes upon that actually. So that is why how they have defined difficulty. I think in this case it is confusing. I think, but I think this is the one. And others, as you can see, weights inversely proportional to the class distribution. Class distribution. Proportional to class distribution. Class distribution. They're not doing something like that. That is for sure. Not sure what they're actually mentioning about class distribution. What do they mean about this? Acha. Okay, you can unmute yourself, nothing problem. You can unmute yourself. Okay, so let's try this problem actually. So binary classification problem where a weak classifier PDF of lecture notes which I actually. But what I've already explained in the PDF, so it means lecture notes. ChatGPT will make mistakes and confusing questions as well. I think this is the one. Okay, see what happens. Okay, so binary classification problem is there. Where a single weak classifier has an accuracy of 60%. So you're combining multiple classifiers through majority voting. The overall accuracy improves. If 5 independent classifiers are combined, What is the probability that ensemble accuracy exceeds 60%? Acha. Okay, so let's look at this. Okay, so say binary classification problem. Well, weak classification flyer has a accuracy of 60%. Okay, through majority voting, the overall accuracy improves. Sure. Okay. So where's the question gone? I'm adding the question wrongly. Acha. So the 60% accuracy is there, and so there's 5 independent classifiers. Okay, and majority voting we are doing. Okay, and okay, it is something like this. Okay, so as you can understand, okay, accuracy has to improve, has to exceed 60%. Okay, so binary classification is there, so it can be true or false. Right answer can be okay. Okay, so that is there. Okay, now what you need is that as you can understand, it can be true or false, means whatever it is definite, right? uh, so next we need to understand is that um, next what we need to understand is that there is 60% chance of predicting the right answer, that is true or false, whatever it may be. Okay, so and we are doing a majority voting. Okay, so the majority should correctly classify, right? Correctly classify. So means that 3 correctly classifies, 2 wrongly, 4 correctly classifies, 1 wrongly, 5 correctly classifies, 0 wrongly. Okay, so we need to sum the probabilities of these 3 situations. Okay, okay, that part is clear, right? Now next what we're about to do is that we're going to find about the probability that 3 classifies correctly while 2 classifies wrongly. Okay, so how do you do this? That is binomial, right? 3c2 0.6 to the power, oh no, got it wrong. So it is binomial, so it is 5, right? 5c3 is correct, so 0.6 to the power 3, 0.4 to the power 2. Correct? Any problem in this? So I'm saying is that 3 classifiers are classifying correctly. Okay, and 2 are classifying wrongly with 0.4 probability. Okay, so this is a situation of binomial. Okay, because you're combining Bernoulli. Okay, you cannot make cases out of true or false. Okay, be it true or be it false, it is something definite. Okay, okay, so I think this is how we're going. Next what we need to do is 5c4, 4 are correctly classifying, 0.6 to the power 4, 0.4 to the power 1, 5c0 0.6 to the power 5, rest is 0.4 to the power 0. Okay, let's see how much is it. 5c3 is 5, 3, 4, 2, 10, right? So this is 10, 0.6 to the power 3. So anybody has done this one, this question? Binayak, Vinotini, Rishank? No? Okay, let's continue. So 0.6 to the power 3. Okay, 0.4 to the power power 2, 0.03456, and multiply 10. 0.3456. Okay, next is this one. This is 5 times, so 0.6 to the power 4, power is multiplied 0.4 to the power 1, multiplied 5, 5c0 is 1. 5c0 is 1, and 0.6 to the power 5. 7776. Okay, so let's see how much is this. 0.2592. 3456. Something like this is the answer. Okay, got it everyone? Clear? Easy? Anybody will reply? Vinayak? Speak up. Agnipo. Got it, thanks. Clear, right? Easy? This is a like clear binomial situation. Okay, so we use the binomial distribution to get the answer. Okay, so let's move on. Next question is, so which one is useful when high variance is there? Bagging is useful. Okay, boosting can also reduce variance, but bagging is more computationally, bagging is better actually. So so how does bagging combines the prediction of the base models? So it is taking average of predictions. Okay, it's the one. third iteration of the adder boost, the weight assigned to misclassified data point is 0.4. Okay, if the initial weight for all data point is 1, okay, what was the misclassification rate of the data point at the end of the second iteration? Acha. So at the third, so d3 is equals to 0.4, it is given. Okay, the initial weight for all data point is 1, it is given. So what is the misclassification rate of this data point at the end of the second iteration? So third is given, we need to find second. Okay, acha, fifth. Okay, fifth answer is uh, first one. So what was I saying? So it is like this, as you can see. What was it? Notes, right? This is boosting. Acha. We go to bagging. Average, right? So models are averaged. Okay. So as you can see, averaging can be voting as well. Okay. So why we are rejecting the second option then? We are rejecting the second option because it is not. It may not be voting. Okay. Can be regression problem. Okay. So their proper averaging is will be there. Okay. So that is why voting cannot be the only answer. Okay. So that is why you are taking the first option. As you can see from here, averaged model. Hmm. Okay, next we progress. Okay, so this is the question. So we start in another slide, another tab here, so you can have access to the theory as well. Okay, so this is the question, so we need to go to the theory as well. So this is the theory. Okay, so so uh, so let me write actually. There are the slides. Okay, so let's start. So it's not very hard actually. Mm, so we'll just go by the formulas and definitions. Uh, so as you can see, for dt plus 1 and for nth example, it is dtn into exponential alpha t. This is the weight. Okay, and this weight is assigned as 0.4. Okay, so let's write it down. dt plus 1 equals to dt into exponential alpha t, right? Simple. And alpha t is here half log 1 minus e to the power t is et, right? Okay, so this is it, right? So weight assigned, so this is 0.4. Okay, and the initial weight for all data points is 1. Okay, so sure. Okay, the second iteration misclassification rate, right? Acha. Okay, so initially it was 1. First is there, then second, third iteration. Acha. Well, let's look at this subsequently. Let's do other problems here. Uh, so, variance is the answer. Okay, variance can be the answer. Actually, it's a multiple correction one. So, model variance, overfitting, model complexity, all three. Okay, should be simple. They're all three related. Okay. These are the answer. Okay, these are all means like with model variance, everything increases. Overfitting, model complexity. So bagging is used to address this. Random forest can handle all three. So that is always the all of above. Simple, right? Any doubt here? Large data set can have large data set because it is a we're training multiple models on that. Okay. linear and non-linear data, any type of data it can work out. Okay, and classification regression as you know, all in the slides as well. Classification and regression both possible. Feature importance in random forest is measured by random forest is bagging, right? So number of instances that user feature importance. Okay, let's see. Random forest. So this is random forest, as you can see. So what's the question? Feature importance. Which feature is more important? Okay. Number of instances that use a particular feature for splitting. Acha, acha, acha. So random forest, you can remember it is a decision tree only, right? So it is dependent on the coefficient value assigned to each feature. Okay, that was the information gain, if you can remember. There are other coefficients as well, Gini, वगैरह. Okay, but got it right. So that is how we get the feature importance. So meta learner, as you can see from this question, meta learner is here. Okay, so there is a final model actually. Final model is called the meta learner, secondary level learner. So what is the question? In stacking, what is meta learning? A model that performs data pre-processing. That's not correct. A based model trained on the original data set. That's not correct. Model trained on the prediction of the base model. Right. This is the one, right? So then see very easy questions. Right. So go back to the discussion. Here it is. So done, right? Everything. Okay. So acha. See, this problem actually cannot be solved if we don't consider this initial weight that is given to be initial weight for the third iteration or final weight for the second iteration. Okay, that is important to consider, otherwise not possible to solve. Okay, 1 e to the power alpha t, right? So alpha t is equals to log 0.4. Okay, so alpha you put log 0.4, 0.4 to the power 2 is equals to 1 minus et by et, right? Next, what do we do? We calculate et here, and et is the answer. Okay, So how much is this? 0.4, 4 is 4 square 16, 0.16, right? So 1 by 80 is equals to just adding this one, 1.16 by 1. Now 80 is this ratio. How much do you get here? Oh my god, what am I writing? So ET is 1 by 1.16, and this is equals to 0.862. Percentage is called how much was misclassified. That is 86%. Easy. Which is already written. So, right, got it everyone? Easy. Understood? Clear, right? So very nice. So we are done with week 6, I think. Week 6 is to us. Week 6. Week 7 is there later. It's also very easy. PCA, LDA. Okay, we'll cover it next time. Thank you very much. Have a nice day.